Hello, welcome to Astronautics for Exploit. I am Dr. Ayashola Ogundele and I will be presenting Cislunar Space. The overview of my presentation is as follows: Earth orbital neighborhood, Cislunar Space region, and lunar orbit. Cislunar Space, a region near the Moon or an area closer to the Earth than the Moon's orbit, and the region of space within the Earth's gravitational influence, which includes the Moon and all the 5 Lagrangian points that are stable in position in reference to the Earth and Moon as they rotate about each other, is the government space agencies and private space companies' next destination of interest. This is due to a lot of potentials and opportunities abound in this region, and the impact cislunar trajectories have on the geostationary belt, where a lot of expensive space assets like geostationary communications and Earth observation satellites are located. Through traveling to and from cislunar space and lunar orbit, the knowledge and experience necessary to venture beyond the Moon and into deep space will be developed. The space companies and space agencies involved in the endeavor of developing space transportation system for in-space transportation and space tourism are using incremental and adaptive approaches. They are using the lessons learned from existing space assets to build new reusable space vehicles. For example, SpaceX Starship for cislunar space traveling. The L1 Lagrange point in front of the Moon and the L2 Lagrange point behind the Moon, each with a distance of about 60,000 kilometers, have been pinpointed for transportation because of their closeness to the Moon. Due to L1 point's ability to afford an uninterrupted view of the Sun, the solar and heliospheric observatory satellite resides in it. The L2 point of the Earth-Sun system was the home to MAP spacecraft, current home of Planck, and the planned home for James Webb Space Telescope. L2 is ideal for astronomy because a spacecraft is close enough to readily communicate with Earth and can keep Sun, Earth, and Moon behind the spacecraft for solar power and provides a clear view of deep space for our telescope. The L1 and L2 points are unstable on a time scale of approximately 23 days, and this requires satellites orbiting these positions to undergo regular course and altitude corrections. Earth orbital neighborhood. The Moon, Earth's neighbor, is Earth's only natural satellite. Earth's Moon contains material and energy resources needed to create a permanent, reusable, and extensible space transportation system. This picture shows cross spacecraft. Development of lunar resources will help humans to create a sustainable cislunar transportation system, unleashing new opportunities for economic and industrial expansion into space. This picture shows moon exploration concept. Advancement of scientific knowledge. Development of a durable space transportation system that can transport people to the moon will help to advance our scientific knowledge and technological base, increase our weight, and secure the nation and the world by expanding into space beyond Leo. This picture shows development of lunar infrastructure concept. Earth neighbor. The Moon, Earth's neighbor, is Earth's only natural satellite, and it orbits Earth at a distance of about 384,400 kilometers, which is about 80 times of Earth's diameter. The Moon's orbit around Earth has a sidereal period of 27.3 days. Moon's gravitational influence slightly lengthens Earth's day and is the main driver of Earth's tides. This picture shows the Moon. Cislunar Space region. Cislunar is a region near the Moon, or the region of space closer to Earth than the Moon's orbit. It also encompasses the region of space within the Earth's gravitational influence, which includes the Moon. This picture shows Cislunar Autonomous Positioning System. Cislunar Space region lies between geostationary Earth orbit and the Moon's orbit. Translunar Space. Space beyond Cislunar Space lies in an area called Translunar Space. This picture shows Cislunar Space between geostationary Earth orbit and Moon's orbit. A lunar vicinity. Cislunar Space is a good region that can be used for Moon exploration. The lunar vicinity orbit can be used as a parking orbit for both manned and unmanned spacecraft. They can also be refueled in this orbit. Spacecraft Control Center can be located in the parking orbit for monitoring Moon exploration activities and space tourists. This picture shows Cislunar Space region. Cislunar Space is a region that is ideal for Mars missions by offering a location for the outfitting and aggregation of Mars transit vehicles and a place to refuel and restore vehicles that return from Mars. This picture shows artistic rendition of the Starship. Cislunar Space includes all the 5 Lagrangian points that are stable in position in reference to the Earth and Moon as they rotate about each other. For transportation purposes, the 2 L points close to and in line with the Moon are being used. This picture shows International Space Station in between the Earth and the Moon region. L1 and L2 are the most important points. L1 is always in front of the Moon and L2 is always behind the Moon. Being in what are essentially zero gravity locations, no entry shells or landing legs are needed for vehicles to visit the station placed there. Large objects placed here in gentle halo orbits can be kept with minimal propellant used for station keeping. This picture shows Cislunar Space. Lunar orbit. The lunar orbit, also known as a selenocentric orbit, is the orbit of an object, for example spacecraft, around the Moon. Various manned and unmanned spacecraft have been launched to the lunar orbit. This picture shows Moon from lunar orbit, with planet Earth rising over the horizon, taken during the Apollo 8 mission. The altitude at apoapsis, the point farthest from the center of attraction for a lunar orbit, is known as apollune, apposition, or apozoline. The periapsis, which is the point closest to the center of attraction, is known as perilune, perizition, or perizoline, from names or epithets of the Moon goddess. This picture shows picture of the Moon. Unmanned spacecraft. Various unmanned spacecraft have been sent to the Moon to examine its nature. Luna 1. On January 4, 1959, Luna 1 became the first spacecraft to be sent to the vicinity of the Moon. It passed within 6,000 kilometers of the Moon's surface, but could not achieve lunar orbit. Luna 3, launched on October 4, 1959, was the first robotic spacecraft to complete a circumlunar free return trajectory, but could not achieve a lunar orbit. It achieved a figure-8 trajectory, which swung around the far side of the Moon and returned to the Earth. The spacecraft provided the first pictures of the far side of the lunar surface. This picture shows Luna 3 spacecraft. In April 1966, Luna 10 became the first spacecraft to orbit the Moon. It studied micrometeoroid flows and lunar environment. Luna 11, launched on August 24, 1966, studied lunar gravitational anomalies, radiation, and solar wind measurements. Lunar Orbiter 1. Lunar Orbiter 1 was launched on August 14, 1966. It mapped the Moon, mainly for the purpose of finding suitable Apollo program landing sites. This picture shows Luna 10 spacecraft. Manned spacecraft. During the Apollo Moon mission, the Command and Service Module remained in the lunar parking orbit, while the lunar module landed on the Moon. This picture shows an artistic concept of NASA's lunar orbital spacecraft at the moon. You've been watching and listening to Cislunar Space. Thank you.